So we'll work on the Kaggle house price data set today. All of you have downloaded the files, right? Train, test, and all. So all of you save those files into a single folder, right? Yes. House price, some name you give, and keep the folder. House price Kaggle data. So this is the data we are dealing with. 1460 rows, 81 variables in train data, 1459 rows, 80 variables in test data. Kaggle house price prediction data set. Okay, all of you have imported the data. Okay, can we proceed? So house train and house test are there, two data frames. House train dot info. So if you look at the house train dot info, we have missing values. Okay. Same house test dot info. Here also we can see there are missing values in similar columns and some additional columns. So we have missing values both in train and test data set. Similar columns as well as some extra other columns are also there. And the sale price is the dependent variable. Sale price of the house is the dependent variable. Sale price is the dependent variable. So we have to do certain amount of pre-processing in this data. So what we will first do is we will combine the data frames so that we can do the pre-processing of the data. So we will combine both the data frames and then do the pre-processing. Okay. So we will follow the same process. For concatenating the data frames, we temporarily add the dependent variable to the test data and fill it with the word test. So we are concatenating train and test for pre-processing. We are concatenating the train and test data frame for pre-processing. For that purpose, we need to have the dependent variable added. So house test square bracket single quote sale price is equal to test. So we are adding dependent variable temporarily to test data. We are adding the dependent variable temporarily to test data. Combine df is equal to pd dot concat house train, square brackets, house train, comma, house test, comma, axis is equal to 0. So basically we are doing row-wise concatenation. Hence, axis is equal to 0. Temporarily add the dependent variable to the test data for concatenation purposes. Okay. All of you are done till this point? Can we move forward? Now, to see a larger output, we need to add set option command. Otherwise, the window size will be very small. You will get output of a lesser size. Constraint size will be there. To do that, pd dot set underscore option display dot max underscore rows comma 82. Right? Now, combine df dot is null dot sum dot sort underscore values ascending is equal to false. Now, if you give the display rows, it will display all the variables. Otherwise, it will not be able to display all the variables. So you have to give how many rows you want to display based on the number of columns you have in your data. So we have 81 variables. So I am giving 82 rows to be displayed. To see the complete output. Otherwise, you will not get the complete output. It will show the first 4 and the last 4 lines. That's all. You will not know the complete missing value picture. If you don't give set option, it will show first 4 and last 4. You will not get the complete missing value scenario. Got this, all of you? So we have significant amount of missing values here, right? And if you go slightly up, you can see there are both types of data, numeric data and object data. You have numeric data and object data. So when you are having such large scale data, it's always better to split the data into numeric and object. Split data into object calls as one data frame and numeric calls as one data frame. So object calls is equal to combine df dot select underscore d types include is equal to square bracket single quote object. So it will take all the object calls into one data frame. Numeric calls is equal to combine df dot select underscore d types include is equal to np dot number. Now np dot number, it will take both float 64 and int 64. np dot number will take both the float 64 columns as well as int 64 columns. So print object calls dot shape print numeric calls dot shape. Include np.float, np.int. You have different data types in NP, float and int, binary, all are there. So we have 44 object columns, 37 numeric columns. We have 44 object columns and 37 numeric columns. Total data size is 81 variables. Number of rows of both data frames is 2919. 44 in object, 37 in numeric. Start using the tab button, 3 letters and tab, 3 letters and tab. Please do not type the complete string. 3 letters and tab, 3 letters and tab. That way you will eliminate a lot of mistakes and also you will also save a lot of time. 3 letters and tab for auto filling. Now find missing values in object calls. Find missing values in object calls. Find missing values in object calls. All right. To find missing values, object calls dot is null dot sum dot sort underscore values ascending is equal to false. What function? That you have to now we have to write. Got it, all of you? Now, if you look at the first 5 columns, there are very, very huge missing values. The first 5 variables, if you look at it, full QC, miscellaneous features, alley, fence, and fireplace quality, there are significant amount of missing values. Now, the reason for this is, will every house has a swimming pool? Not, right? So, we can assume that that feature is not available for that house. Will every house have an alley access? Alley means back access. In US, alley access will be rare. It is costly. You have to pay additional taxes and all. So, alley access will also be not there. Similarly, fencing. In US, if you want to put a fence to your house, you have to pay extra tax. That is why fence will not be there for every house. Will every house has a fireplace? No. Not all houses will have fireplaces. Similarly, miscellaneous features. Miscellaneous features like burglar alarms, miscellaneous features like electric fences, miscellaneous features like automatic gardening, or what you call water sprinklers, sensors, like that. Miscellaneous features will all houses have? No, right? So we can assume here that these 5 missing values means those features are not available for that particular house. So we will impute with the word not available. We'll impute with the word not available. Since these features are not regular features for every house, so we can assume that those features for those houses are not available. So we will, what you call, fill the missing values in these 5 variables with the word not available. Okay. Now, what are those variables? First, object calls dot columns. Like I told you, always print the columns and copy from there. So, not available calls is equal to square bracket alley fireplace quality pool QC fence and misc feature. Pool QC and misc feature, 5 columns, right? 1, 2, 3, 4, 5. So I've created a list of the variable names. For call in not available calls, colon, object calls, square bracket call is equal to object calls, square bracket call, dot fill NA with the word not available. We are filling it with the word not available. That particular feature is not available for that particular house. Alley, fireplace queue, pole QC, fence, and misc feature. Print the dot columns. You will get the column names. Copy paste from that. Please do not type. Right? Got it? Now, if you go and run the previous command of the missing values, object calls thing, if you run this, you should see all of them are gone. All the missing values have been imputed. If you go to the previous object calls is null line and run it, you can see now all of them has gone. Now, the second set of missing values are in garage. Garage condition, garage quality, garage finish, and garage type. 159. 159 of 2019 is less than 5%. Right? Very small missing values are there. We can fill it with mode. We can fill it with mode. We can fill it with mode or most frequent. Now, if at all you want to still understand the frequencies of these four variables, I want to study the frequencies of these four variables. Confirm that I can do it with most frequent or mode imputation. You can do it like this. First, we need to create a list of all these four variables, like how we created. Then we will write a for loop where we print the value counts. We do the for loop where we print the value counts. Right. Now, in industry, you will often come this scenario where the variable name starts with particular set of characters. Like in this case, all the garage columns are starting with the word garage. Now, instead of manually selecting, you can write a simple function that will help you to select it. Garage underscore list is equal to square bracket call for call in object calls if call dot starts with, you can give the first three, GAR. For call in object calls, if call dot starts with garage list. Now you can see all the four columns have been automatically selected. Either you can use starts with or you can use ends with. Sometimes based on your variable structure, you use starts with or you will use ends with. So in real-time data science, instead of manually selecting the variables, we do this type of list creation. Starts with is a string function which will help you to identify all the variable names that start with a particular set of letters. Now it has selected all the columns. Now you just need to write a simple loop. For call in starts with, you have to specify the first three letters, or you can specify the first four letters or full name also, but preferably 3 letters should be enough. For call in garage list, colon object call, sorry, frequency is equal to object calls square bracket call dot value underscore counts drop NA is equal to false and print frequency. For call in garage underscore list colon, frequency is equal to object call square bracket call dot value counts drop NA is equal to false print frequency. Now you can see the frequency of all the variables including the missing values.
Also find missing percentage values.
Yes, you can do that also. You can do that also. Simply divide it by shape square 0, you can do it. You can do that using that also. See, that additional thing you want, we can do it. But based on that, we can easily assume that now we can make out the percentages in our mind itself. If you still want, you can add that command, write the combined is not divided by shape. Data frame dot shape 0 square bracket 0, you'll get the percentages. So right now, I think you must all be familiar now with mentally calculating the percentages. Right. So you should be able to now and look at the number and calculate. If you want, you can write the function. That's not a problem. Okay. Now, if you observe, the largest category is very high, so we can do mode frequent mode what you call mode imputations. We can do mode imputations, right? Okay. Now do the same thing for BSMT calls. The next set of missing values are in BSMT. BSMT means basement. B capital. If I scroll up, after garage calls, the next set of variables that have missing values are BSMT calls. BSMT means basement. B capital BSMT. Now you also do the same thing. Create a list of basement calls and find out the frequency of the basement call so that we can do everything in one go. Create a basement list, BSMT list, and print frequency of the BSMT list. All of you are getting this? Anybody is having errors? Okay. So BSMT underscore list is equal to square bracket call for call in object calls if call dot starts with BSMT. BSMT list. Right? You got all the BSMT list. For call in BSMT list, column frequency is equal to object calls square bracket call dot value underscore counts drop NA is equal to false print frequency. Here also we can do mode imputations. Mode imputations can be done, or most frequent imputations can be done. Similarly, if you look at other missing values, they are very, very small. They are very, very small. You can do the mode imputations by default. So you can say we will do mode imputations for all the missing values in the data. Mode or most frequent imputation for all remaining variables in object calls, right? So we have run the loops to understand the missing values in both garage calls and the basement calls. And we found out that we can do with mode or the most frequent. Similarly, if I go to the missing values list, very few missing values are there in other variables, which are very, very less. So less than 1%. So we can do mode or most frequent imputation, which will not affect our analysis. So for call in object calls dot columns colon object calls square bracket call is equal to object calls square bracket call dot fill NA object calls square bracket call dot value counts object calls dot value counts dot IDX max. Dot IDX max. First table create, then identify the maximum value, index of the maximum value. Index means name of the maximum value. Now let me check if this worked or not. I will go back to the top and run this command again. Now all the missing values are gone. So this is a simplistic loop which you can write for call in object calls dot columns colon object call square bracket call is equal to object call square bracket call dot fill NA object call square bracket call dot value counts dot IDX max. So it will loop through each variable one by one. If it has missing values, it will do the value counts, identify the frequency, largest frequency, and corresponding index of the maximum frequency will be used as the imputation. All right, done, all of you? Done? Whoever is done, find the missing values in numeric calls. Whoever is done, please find the missing values in numeric calls. Done, numeric calls missing values. Numeric calls dot is null dot sum dot sort underscore values ascending is equal to false. To check the whether it is correct or not, whether most frequent can be done or not, you have to check, right? Before blindly doing it, we have to check whether there are differences in the most frequent can be done or not. Whether there is a big gap between the first class and the second class. If it is there, then we'll do most frequent. If the gaps are very small, you can't do anything if the missing values are large. But here, very small missing values, so we can directly go and fill them with most frequent, less than what you call 5%, right? Very small missing values are there. So we can do most frequent directly. Now, if you look at this numeric calls, you have something garage year built. Garage year built is there. Then month sold, year built, year remodel. So we have some categorical variables. Always remember, within numeric calls, within numeric variables, there might be categorical variables, and categorical variables must be separated from numeric variables. Now, you have to be very careful when you're looking at numeric columns. There might be some categorical variables. What are the typical categorical variables we can see? Typical categorical variables like year, ratings, etc. or dummy encoded. Dummy encoded means 0 or 1, etc. So these are the types of variables which will be numeric variables, but you cannot treat them as numbers. You have to treat them as categories. You have to treat them as categories. So whenever you look at your numeric data, make sure you are identifying these categorical variables. Now, how do it? By inspection and also comparing them with the data dictionary. There is a data dictionary text file also which you have downloaded. There, every variable's detailed description is given. So from that description, we can find out the year, YR or year represents years or dates. So we have certain categorical variables which needs to be separated from the numeric variables and they have to be treated separately.
So for example, if you have employee IDs.
IDs will delete. All IDs will be deleted. Before deleted, if you find any information to be extracted, you will extract it. Otherwise, all IDs will be deleted. Because they are unique IDs. 2000 unique IDs will be there. When will your model end? That means it will have to create 2000 independent variables. That is not possible.
So, I mean, at the end of that,
IDs will be deleted permanently. You cannot have that many IDs because each ID is unique. That many levels of independent variables will be created. Your model will never build.
what about periods? Dates.
Dates, that's what we have to extract. Year, month, quarter, weekday, like that we extract and then we delete them.
But in big smart data, we haven't considered IDs and dates.
That's what now we have extracted. We have extracted data, right? From year we have extracted age. From IDs we extracted item codes. Without extract, see, not all IDs will be extractable. Some IDs you directly delete it. Here you have different house IDs. What is the point of having house ID? They are simply number. Now, if you put it in a dependent variable with 2000, what we call 1460 levels, your model will never be built. 1460 levels means what? It's impossible to build a model. Your model will obviously fail. IDs are always unique, right? You cannot include them in model building. We will simply delete them. Now, numeric calls dot columns. Category calls. Category calls is equal to numeric calls double square bracket. Now you can see here overall quality is a rating scale. If you read the data description or data dictionary, overall quality, overall condition, year built, year remodeled. These are all categorical variables. Then what else? How about garage year built, comma, then would take month sold and year sold. Month sold and year sold. So these are the categorical calls which are there in the numeric calls. Now immediately you will drop them. Now numeric calls is equal to numeric calls dot drop. You select the from square bracket to square bracket, comma, axis is equal to 1. Now 37 is a numerical call count. Print category calls dot shape print numeric calls dot shape. So 7 and 30. So we have 7 categorical calls in our data and 30 numeric calls in our data. So we have now 3 data frames: object calls, category calls, and numeric calls. Saturday will be online. Will be online. So the Saturday, Sunday, we have some racing going on in that tank bund area. So I'm not sure those roads will be blocked. So Saturday, Sunday we'll have an online class.
No exams.
Exam will be online. You'll get a link of test link.
Sir, again class will be there. Again class will be there.
No. Saturday you will have to log into the Zoom link. I'll give a test link. You have to complete the test. Then I'll give you a data set to work upon. You will work on that. Once you get the data set, you can log off. Data set to work. That by 8 PM in the evening, you have to submit.
So test link is on.
Yeah, it's MCQs.
Very good.
What is this categorical columns where
Huh?
very category column critical variable
I didn't get you.
like I can't ignore the critical variables. So what is this category?
We are not ignoring them.
That is the problem.
We didn't drop anything here. We have separated them into a new data frame. We have to label and code them. We have to do a lot of other process on them. Category calls need to be labeled and coded. We are not going to drop. We are dropping from numeric calls so that it is not duplication of calls. There is no drop. We are creating 3 data frames now: object, category, and numeric. Object and category must be labeled and coded. And the missing value imputation is most frequent, not numeric. So you have to do it. It's different missing value imputation. That is why we are separating. We are not dropping anything here. All right, all of you got till this point. So category calls dot is null dot sum dot sort underscore values ascending is equal to false. So we are missing value in garage here build. We are missing values in garage here build, which is very less. So we can do with most frequent imputation. category calls dot garage year built is equal to category calls dot garage year built dot fill NA. Category calls dot garage year built dot value counts dot IDX max. Okay. So Saturday, if you guys want, you can come and sit in the classroom and you can do it from here. You can work together and you can work from here also. That's not a problem. If it is an online class, you can, if you want, you can come here and attend also. I'll try to see. Hello. మసీదు ముందుకు రా అమ్మా, ముందుకు వెళ్తే లెఫ్ట్ సైడ్ 5వ అపార్ట్మెంట్ సాయి మోహన్ ఎన్క్లేవ్. పింక్ కలర్ అపార్ట్మెంట్ కానీ బ్రౌన్ గేట్స్ ఉంటాయి. మసీద్ దాటి అటు పోవాలి, నాలా వైపు మెయిన్ రోడ్లో ఉన్నావు కదా. అదే మసీద్ రోడ్లోకి వెళ్ళు, మసీద్ ముందు రోడ్డే కదా. ఏం బేకరీ వచ్చింది? అది కాదమ్మా, మసీదు ఎదురుగా పెద్ద కాంప్లెక్స్ ఉందా? మసీదు కాంప్లెక్స్ మధ్యలో రోడ్ ఇది. రిలయన్స్ స్మార్ట్ పక్కన మసీద్ అమ్మా, సిగ్నల్ దగ్గర మసీదు కాదు. అడిక్మేట్ రోడ్లో రిలయన్స్ స్మార్ట్ పక్కన మసీదు ఉంటుంది, ఆ మసీద్ రోడ్లో. All right. So with this process, we have completed the missing value imputations. Now, the next process is label encoding or dummy encoding, object calls and category calls. Object calls and category calls must be label encoded or dummy encoded. Now, in this case, our data is limited. We have 1450 or 1460 rows only. So we can't do get dummies, because get dummies will increase the variables, right? It will increase the variable columns. So we can't do get dummies here. We will go with label encoding. Okay. From sklearn, yeah. You cannot have variables greater than rows. That is fundamental statistical rule. Import label encoder. LE is equal to label encoder. Object calls underscore encode is equal to object calls dot apply LE dot fit underscore transform. Okay, we have a small issue here. One second. Numeric calls square bracket sale price is equal to object calls dot sale price. Object calls is equal to object calls dot drop sale price comma axis is equal to 1. So before running the label encoder, we are moving the sale price to numeric calls. It is a mixed data type, so it is coming in object calls. So we are moving it to numeric calls. Then we are dropping it from object calls. Then we are encoding the object calls. Yeah. You can do mean or median, your choice. I used median. Mean or median, your choice. But to be on, if you don't want to do descriptive statistics, you want to be on safe side, use median. You can use anything, your choice. I told you, mean and median are distant. Then you have to use median. That you will find out how when you do descriptive statistics. Here I have not done descriptive statistics. I have directly taken it median. The values are very small, missing values are there. It will not affect the data. If there are huge amount of missing values, then I have to do descriptive statistics. do the mean and median. Then if you mean and median are different, then I'll go with median. If both of them are close, we can go with mean. The process is same. Here I have, because it's a very small number of missing values, I am just going with my median. You want, you can do mean imputation. Here only hardly very less missing values, right? If the missing values are larger, then you have to do analysis. Mean analysis, median analysis, then you have to compare those two. If there is distance, then use median. If they are closer, you can use any one of them. But if you are on a smaller things, you don't want to do any analysis and don't waste time, so go with median. Safe side thing. So it is your judgment, because this is a very small data, missing value, so I am doing it. If it is a larger missing value data, I have to do the analysis also. So based on the amount of missing values, you decide. Here hardly 5%, less than 5% missing values are there.
Okay.
By default, if it is a mixed data type, it will go into object calls. Mixed data type means half of it is numbers, half of it is character data or text data. It will go into object. But actually the basic data type is numeric. You cannot label and code numeric data. It has to be moved to the numeric calls. Later we will separate them, and then we will, what you call, using the test as a conditional operator, we will separate the data and then we will drop it. Then we will convert it into numeric data. So process, you have to remember, this is the same process you need to follow. Hello. Good morning. Good morning. ఏది పరిస్థితి బాగాలేదు కదా నిన్నటి నుంచి. ఇవాళ కొద్దిగా బిజీగా ఉన్నాను, చెప్పలేను, గ్యారంటీ అయితే ఇవ్వలేను. చూస్తాను, నేను ఫోన్ చేస్తాను. హలో, లోపలికి రా, మసీద్ గల్లీ లోపలికి వెళ్ళండి. పెద్ద గల్లీలోకే కదా, మసీద్ ముందు. అది కాదు, అది కాదు, అది అది చిన్న గల్లీ అమ్మా, ముందు మసీద్ ముందు గల్లీ. గలీలోకి వెళ్ళు, స్ట్రైట్కి వెళ్ళు, లెఫ్ట్ సైడ్ 5th అపార్ట్మెంట్. స్ట్రైట్గా వెళ్ళు. ఇంకా ముందుకి. ఇంకా ముందుకి. ఆర్బిఎస్ డక్కన ఎదురుగానే సాయి మోహన్ ఎన్క్లేవ్. ఎదురుగా ఏం అపార్ట్మెంట్ కనపడుతుంది? ఇంకా ముందుకు రండి. ఇప్పుడు ఏం అపార్ట్మెంట్ కనపడుతుంది? దాని తర్వాత రెండో అపార్ట్మెంట్ ఓం శాంతి పక్కన పూర్ణిమ మ్యాన్షన్, పూర్ణిమ మ్యాన్షన్ పక్కన సాయి మోహన్ ఎన్క్లేవ్. దాని పక్కదే సాయి మోహన్ ఎన్క్లేవ్. దాని 3rd floor 302 క్యాలెండర్. All right, done till this point. So we have label encoded both the object calls and numeric categorical calls. So object calls encode dot head. See, all of them have been converted into numbers. What is actual object calls? Text. Original object calls is text. The encoded version is numbers, dummy encoded numbers. Similarly, category calls. We have the years, conditions, rating scales and all. Underscore encode dot head change to numbers. Right? Now, before we go ahead and combine the data, let us check numeric calls. Numeric calls dot drop sale price, comma, axis is equal to 1 dot CORR. So what I am basically doing here? What basically I am doing here? I am trying to find the multicollinearity or the correlation analysis. What I am trying to do is correlation analysis to find multicollinearity. Okay. Now, if you see here, do you see what you call multicollinearity in the output? So basically, we are checking for multicollinearity. Check for multicollinearity. Now, this is a very large matrix, right? Manually getting the thing is little bit difficult. So you have two options. You can use the seaborne heat map to find it. SNS.heatmap will help you to find it out. Okay, all of you done till this point? While checking for multicollinearity, all of you are done? Correlation only will tell you now whether there is a relationship or not. Correlation itself will tell you whether there is a relationship or not. For categorical variables, you have to do t-test, chi-square test and all you have to do with your numerical variable. Where S capital, P capital, access equal to 1 dot CO error carrot. Scroll down. That means you have given sale price wrong. Check. यहाँ पे क्या नाम दिया आपने? S capital, P capital दिया. गलत. Got it? Okay. So when you have very large correlation matrix, you have two options. You can use seaborne heat map to check the multicollinearity, or you have to write the file into a CSV file. And then use conditional formatting color scales to find out. You have to write the output into a CSV file and then use conditional formatting in Excel to find the color scales. And then you find it out. I will show you both the processes, how to do that. First, let us do the seaborne. Import seaborne as SNS. PLT.figure fixed size is equal to 30,15. SNS dot heat map you can copy the numeric calls code comma anot is equal to true plt dot show. You can choose your own thing. Window size you want, you can increase or decrease based on your requirement. Plot window size, your choice. You can give, basically it is length and width. Sorry, width and length. Anot means numbers. Annotations. Annotation means numbers. If you don't give anot is equal to true, you will only get the color scale. Okay, I can interpret this because I can see the whites. If any whites is there, then multicollinearity is there. But till you gain experience, you add annotations is equal to true, which will add numbers to the data. Annotations means numbers, data labels. No, this is the correlation thing, no? Yeah.
Like this sales value. Must be moved from numeric calls to object calls and then object. So
from object calls to numeric calls. We moved it from object calls to numeric calls. It will be in object calls. By default, it will be in object calls. Because it's a mixed data type. Any mixed data type will be by default in object calls. So when you split the data, select underscore details, sale price will go to object calls directly. From object calls, we are moving to numeric calls and then dropping it from object calls. Because label encoder will not work if it is a mixed data type. Label encoder will not work if it is a mixed data type. For label encoder, the data type should be single, either int, either float or string only, not mixed. So mixed data types by default will go into object only. So when you do the select underscore d types in the top, sale price will be defaultly go into object calls. So if you look at the correlation matrix, there is no whites. There is no white colors. That means there is no multicollinearity. There is no multicollinearity in the data. That is correlation between the variable itself. That is variable to variable. This is MS subclass with MS subclass. You should not look at the diagonals. You have to look for values other than the diagonal. Diagonals are correlation between itself, variable and itself only. You have to look for non-diagonal values. That means there is multicollinearity. Then what do you have to do? If there is multicollinearity, drop any one of them. So the maximum correlation is 0.89, right? Maximum correlation is 0.89. You can see here 0.89 between garage area and garage cars. No, garage area and garage cars, I think. Garage area and garage cars, that is the maximum correlation of 0.89. We don't have anything above 0.95, which is the multicollinearity threshold. Okay, all of you got this? Multicollinearity. Numeric calls dot head. So, should we scale or not? We should scale the data because we have in tens, individual single discrete values, we have in thousands, tens of thousands. So we have values in different scales. Except sale price, we have to do for all other scaling. Scaling must be done because the data is in multiple mathematical units. From sklearn dot preprocessing import standard scalar. Scalar is equal to standard scalar. Numeric calls underscore scaled is equal to numeric calls dot drop sale price comma axis is equal to 1 dot apply scalar dot fit underscore transform.
The column is at the end, you can use dialog.
scalar dot get underscore transform okay, standard scalar, then we fit the scalars, then we convert it into data frame. So copy from the numeric columns output the column names. Or I think we can give list comprehension numeric calls dot columns square bracket 0 colon 30. Okay, you can give like this 0 colon 30. Okay. Combine df underscore clean is equal to pd dot concat numeric calls underscore scale, comma, object calls underscore encode, comma, category calls underscore encode, comma, axis is equal to 1. Resetting the index is the problem. So we have to reset the index and then combine the data into one single data frame.
So reset index would happen.
Row numbers will be resetted to 0.
So all
0, 2, 1, 2, 3 like that. The resetting index means freshly starts from 0, 1, 2, 3 like that it will start.
whatever is there in numerical column it shows 0, 1, 2, 3, 4, 5, 6. And the object column is 0, 1, 2, 3, 4, 5. So how are we combining them?
We are just copy paste. See, some on the screen you are seeing one index, in the back end there will be another index. That is what it's saying. A duplicate index has been created in the back end. So once we reset it, both the indexes will be of same type. Because we are doing the transformations will alter the index. Whenever you get an error called re-indexing error, you have to reset the index. That is a thumb rule. Re-indexing means the matching numbers are not there in the data frames. We are adding the dependent variable back to the data. We dropped it when you scale the data, right? When you scale the data, it was dropped. Now we are adding it back to the train data frame. All right, you can take your break. We'll meet after. your break. Meanwhile, I'll send the notebook also for your reference. So we have pre-processed the data before the break. Now we are ready to split data into Y and X. Y is equal to house train underscore DF dot sale price. Capital X is equal to house train underscore DF dot drop square bracket single quote ID comma sale price comma axis is equal to 1. ID small letter. House test DF is equal to house test DF dot drop ID comma axis is equal to 1. So we have to drop it from tested data also. Y is equal to Y dot as type. I think it is all whole numbers, right? Int 64. Now create box plot, histogram and density curve for Y. Got it? Where? What is the name you have given to the data frame? Corrected it?
Depending on its weight, there's something called index also. Okay. You might have run this through, right? If you run it, you will not even you might have not corrected the access properly. Running the command. See, if you go back and run it again, it might corrupt the data. So first correct the error and go back and correct it. If you don't correct the error and go back again and do this, it will not work. Yeah. Because it is mixed type now, yeah. It will be object type only, no? What was the mixed type? All right. You guys have very short memory here. Index is also there, huh? Okay. Then You will split the data. Now, y dot d type. What is it showing us? It is object. Oh, why it is showing as object? Because it was a mixed data type earlier. Can you do plotting on object data? Then what we have to do? Then index is still there. Index and ID both are there. Okay. So find here dot sale price. Okay. Then this we have to add one more column, index. Here also we need to add square bracket, comma, single quote, index. Now y as type integer. So run the where you are splitting the house train DF command again. Then drop the sale price. Then in X add index also. There's a column which because we have reset the index has come into column, so we have to delete that also. So whenever you reset index, use drop is equal to true. All right, got it, all of you? Yes? Positive skewness is there. Y dot plot kind is equal to box, comma, what is equal to false. We have outliers. NP dot log of y dot plot kind is equal to box, comma, what is equal to false. So box is moving to the middle and outliers are also spread on the both sides limited. So we can say logarithmic transformation is working to some extent. To some extent, logarithmic transformation is working on this data. So we found out that y is positively skewed and I have done logarithmic transformation, which is to some extent moving the box to the middle and outliers also slightly reduced. Outliers are on the both sides, but the outliers are also reduced.
Hello?
Sairam. Yeah, this is, hello. These students are, right? So logarithmic transformation is working. Now let us build our model. From sklearn dot linear underscore model, import linear regression. Reg is equal to linear regression null brackets. Reg model is equal to reg dot fade x comma y. Reg model dot score x comma y. 85.44 is the R square. Which is a good R square. Reg test predict is equal to reg model dot predict house test df. PD dot data frame reg test predict comma 2 underscore CSV reg dot CSV. Write the predictions to a CSV file. Hello. గచ్చిబౌలిలో ఉన్నాను నేను అక్కడికి 1 గంట కల్లా రావాలి ఇక్కడ నుంచి నేను అదే అశోక తూప్రాన్పేట వెళ్ళాలి కదా అశోక స్కూల్ ఆఫ్ బిజినెస్కి కాదు 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 గచ్చిబౌలి నేను గచ్చిబౌలిలో ఉన్నాను గచ్చిబౌలి పంపించాలి వెహికల్ టెలికాం నగర్ బస్ స్టాప్ నేను లొకేషన్ పంపిస్తాను మీరు అక్కడికి పంపించండి లొకేషన్ షేర్ చేస్తాను అక్కడికి పంపించండి ఆల్రెడీ నేను లొకేషన్ షేర్ చేశాను కదా మీకు రాలేదా లొకేషను హలో హలో, ఇది లొకేషన్ వచ్చి టెలికాం నగర్ బస్ స్టాప్, గచ్చిపోలి ఫ్లైఓవర్ దగ్గర స్టార్టింగ్ లోనే లెఫ్ట్ సైడ్ ఉంటుంది. టెలికాం నగర్ బస్ స్టాప్ దగ్గరికి రావాలి. రిటర్న్ విద్యానగర్, రామ్నగర్ విద్యానగర్. పికప్ అయితే గచ్చిబౌలి నుంచి పికప్ గచ్చిబౌలి టెలికాం నగర్ బస్ స్టాప్ దగ్గరికి. All right. Now you can copy. Did you copy the values? into sample submission. So this is the sample submission file where you have the sale price. This is the predicted files below 0. Control Shift down arrow, Control C. Go to the sample submission file under sale price. Paste that. Control S. Save the file. Do not touch the ID column. Do not touch the headers. Kaggle competitions. House prices competition. Submit predictions. Click on submit prediction. Browse files. Desktop. Hackathon. House price prediction. Sample submission. Click open. MLR. Now submit. 0.3559. 0.3559. If you look at the leaderboard, 0.004. So 0.3559 will be 3,987. 3,987 rand. So with basic multiple linear regression, we got 0.35590. So copy the predictions into the sample submission file and then go and submit predictions in Kaggle. You will come to know your score. Okay, try that.
Index not known.
హలో ఎక్కడున్నావమ్మా? ఇది గచ్చిబౌలి రావాలి. ఇది అశోక బిజినెస్ స్కూలే కదా? గచ్చిబౌలి టెలికాం నగర్ బస్ స్టాప్ దగ్గర రావాలి.